Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on equivalent force system. Now before I move on, I suggest you to please watch the video lectures on equivalent force systems one by one in sequence so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the problem. Now the problem is find the moment m at point O. This is point O. We have to find the moment m at this point such that the force system shown in figure 1-5-A, this is figure 1-5-A, okay, is equivalent to a horizontal force of 10 kilonewton at O towards right and a moment m. Now let me tell you what it is saying. Now let me change the color first. Now let us say this is system 1, and we have another system here. This is system 2, okay, this is point O, this is point B, this is point A. This is system 2, okay. Now they are equivalent to each other, okay. Now what does it mean? It means summation of all the forces in this system is equal to summation of all the forces in this system, and summation of moment at any point in this system is equal to summation of moment at any point in this system, okay. Now in figure 1-5-A is equivalent to a horizontal force of 10 kilonewton at O, okay. So let me show you. Now is equivalent to a horizontal force of 10 kilonewton at O. Now this is the point. Now this is point O. We have a force like this, okay. It is towards right, okay. It is equal to 10 kilonewton, okay. Now these two are equivalent, and there is also a moment m, right. Let me assume the moment is clockwise, okay, and a moment m at point O. Now these two systems are equivalent, right. This is system 1 and this is system 2. Now because these two systems are equivalent, it means summation of forces in system 1 is equal to summation of forces in system 2, okay. Now let's assume this to be x-axis, positive x-axis, and this to be positive y-axis, okay. This is positive x-axis. Now what does it mean? It means summation of forces in system 1 along x is equal to summation of forces in system 2 along x, and also summation of forces in system 1 along y-axis is equal to summation of forces in system 2 along y-axis, okay. Now also because they are equivalent, it means summation of moment in the system 1, okay, system 1 is equal to summation of moment in the system 2, okay. Now what we have to find? We have to find this moment m. We have to find this moment, all right. Now let's apply each equation one by one, and from these two equations we will get f1 and f2, because f1 and f2 are unknowns. We don't know what is the value of f1 and f2, so these two equations, they are going to give us the value of f1 and f2. Then we will find the moment m. We have to find this moment m. We will find this using this equation, okay. So now let us say this is f1x, okay, that is x component of f1. This is f1y, okay. I am resolving f1 force into x component and a y component. Similarly, I will resolve this f2 force into f2y y component, and this is f1, this is f2x, right, f2x, okay. Now let's apply this equation first. Now f1x, now f2x, it is towards left, which is against this direction, so it's negative, so I'll use negative in the equation, minus f2x, right. This is the summation of forces in system 1, right, in along the x-axis. Now it is equal to summation of forces in system 2 along x-axis. Now what is the summation of forces in this system 2? Now you can see 10 kilonewton is in the x direction, right. As you can see, this is the x direction. This is 10 kilonewton towards the right. So summation of forces in this system along x-axis is 10 kilonewton, okay, plus 10 because it is towards the right. So it is equal to 10 kilonewton, okay. Now f1x is what? f1x is f1 cos of, let us say this is theta. f1x is f1 cos theta, and f1y is f1 sine theta, right? Now f1x is f1 cos theta, okay. Now minus f2x. Now f2x is what? f2x is f2 sine 30, right? Because this is 30 degrees and this is the normal component, so f2x is f2 sine 30 degree minus f2 sine 30 degrees is equal to 10, okay, kilonewton. I know it's kilonewton and I'm not going to write that. Now let's first find the value of theta. Now theta is tan inverse of, if I assume this to be a right angle, now then theta is tangent of perpendicular divided by base. So it is, now the perpendicular is 1 and the base is 1. It is 1 divided by 1, right? And tangent inverse of 1 is 45, okay. So it means theta is 45 degrees. So I put here cos 45 degrees. Cos 45 degrees is what? It is square root of 2 divided by 2. So I will write here uh, f1 multiplied by square root of 2 divided by 2 minus f2. Now sine 30 degree is 1 divided by 2, okay. It is equal to 10. Now let me call this as equation first. Now let's apply equation second. This is the now let's apply this summation of forces in system 1 along y-axis is equal to summation of all the forces in system 2 along y-axis, okay. So in this is the system 1, in the y-axis we have to sum up all the forces. Now in the y direction, there are which forces are in the along the y direction or in the y direction. Now f1y, it is in the y direction, also f2y, it is in the y direction, so I have to sum up them all, okay. So this is the system 1. Let me first write f1y. Now they are both upwards along this direction, so they are both positive, okay. f1y plus f2y is equal to, now I have found the summation of all the forces in y direction in system 1. It is equal to summation of all the forces, this is system 2, right, along y direction. Can you see any force in system 2 along the y direction? No, there is no force along the y direction in system 2. So summation of forces in system 2 along the y direction is 0. So it is equal to 0. Now f1y is what? f1y is f1 sine 30 theta, right? And theta is 45 degrees. So I will write f1 sine 45 degrees. Now f2y is what? f2y is f2 cos 30 degree plus f2 cos 30 degree, it is equals 0, okay. Now again, now sine 45 degree, it is f1 square root of 2 divided by 2 plus f2 cos 30 degree is what? Cos 30 degree is square root of 3 divided by 2, okay. It is equal to 0. Let me call this as equation second. Now this is, we have two equations and we have two unknowns. The two unknowns are f1 and f2, right? Now if you use a calculator, you put the two equations and two unknowns, you will get the value of f1 and f2, okay. And also you can find it like this. How you are going to do that? Now f1 root 2 by 2, f1 root 2 by 2, they will cancel out if I subtract them. You see, I will do what? I will do, let us subtract equation first from equation second, okay. equation second minus equation first is how much? Now equation second is this, f1 root 2 plus this. Now f1 root 2 by 2, f1 square root of 2 by 2, they will cancel out, right? Then we will have f2 root 3 by 2, then this is negative and we have to subtract them, then negative and negative will be positive. So what we will get? We will get f2 square root of 3 divided by 2 plus f2 multiplied by 1 divided by 2, it is equals. Now equation second minus equation first, it is 0 minus 10, right? Because we have added these are the left hand side, we have subtracted the left hand side of this equation. Okay, we have subtracted the left hand side of this equation from this equation. It is equal to, we will subtract the right hand side is 0 here and the right hand side is 10 here, we will subtract them. So 0 minus 10 is minus 10, right? It is minus 10. So how much is it? Now f2 divided by 2, f2 divided by 2, we'll put it common, f2 divided by 2. Now it is square root of 3 plus 1, square root of 3 plus 1, it is equal to negative 10, right? So from here I will get the value of f2. f2 is 2 multiplied by negative 10, right, divided by square root of 3 plus 1. Now negative 10 multiplied by 2 is negative 20. Now let me use a calculator to find the value. Okay, I get the value to be negative 7.32 kilonewton. Okay, so let me write this value here. F2 is equals negative 7.32 kilonewton. Okay, now let's find the value of F1. First let me erase all of this first. I will use the equation 2. Okay, now let me use the equation 2. F1 root 2 square root of 2 divided by 2 plus f2. Now f2 is negative minus negative 7.32, negative 7.32 multiplied by root 3 divided by 2, right? Root square root of 3 divided by 2, it is equal to 0, right? So let me erase this first. What we get, it is 0. Now from here we will get the value of f1, right? Now when you take this to the right side, you will get it is equal to this. Now 2 and 2 will cancel out, so f1 is equal to 7.32 multiplied by square root of 3. Now square root of 2, it will come in the denominator, right? Now this is square root of 3 divided by square root of 2. I can write it like this, whole square root of 3 by 2, right? So f1 is 7.32 multiplied by whole square root of 3 divided by 2. So let me use a calculator. 7.32 multiplied by square root of 3 divided by 2. Okay, it is 8.965 kilonewton. Okay, so let me write it here, 8.965 kilonewton. Okay, so let me now erase all of this. Then we will apply this third equation. We will find the value. We have to find the moment at point O. We will get it using this equation. So let me first erase all of this. Okay, now let's apply this equation. Now let us find the moment at point O in system 1. Okay, now what is the moment at point O in system 1? You see, we will apply Varignon's theorem here. If you don't know about Varignon's theorem, you see we cannot find directly the moment of F1 at point O because we don't know the normal distance between F1 and O, because F1 is like this, so the normal distance between O and F1, let us say this is F1, it is going to be something like this. Okay, this is the normal distance, this is the normal, which is very hard. So what we are going to do, we will find the moment of the components of F1 about O, which is the same thing. Okay, if you want to find the moment of F1 about O, it is the same thing. We will find the moment of F1's components about O. Okay, so let us apply the Varignon's theorem. If you don't know about Varignon's theorem, you can watch my video lecture on Varignon's theorem. So let us do it now. F1y is passing through O, so the moment due to this is going to be 0, so I will erase this to simplify the diagram. Now this F2x is passing through point O, so there will be no movement due to F2x at point O, so I will erase this. Now movement at O will be only due to F1x and F2y. Okay, I will also not find the movement due to F2, okay, because we don't know the normal distance between F2 and O, right? Because moment is force multiplied by normal distance. How much is this? It is really hard to find, right? So this is the component of F2. We will use this component. Okay, that's all the Varignon's theorem says, right? Now let me apply. Now F1x is going to apply a clockwise movement at point O like this. Okay, and I assume clockwise movements to be positive, and F2y, it is going to exert moment like anti-clockwise, so it is going to be negative. Now F1x multiplied by, how far is F1x normally from point O? This is point O and this is F1x. The normal distance between them is this 2 meter, right? Multiply by 2, right? Minus, because F2y is going to exert an anti-clockwise movement at O, minus F2y. How far is F2y normally from point O? It is this distance, right, which is 4 meters. Multiply by 4. Now this equation is what? This is the moment in system 1. It has to be equal to the moment at O in the system 2, right? Now what is the moment at point O in the system 2? It is m, right? It is in the clockwise direction, so it is positive. We had to find this m, right? Because we had to find the moment. M is the moment. Now F1x is what? F1 cos 30, cos theta, right? Now theta is 45 degrees, so it is F1 cos 45 degrees, right? As you can see, theta is 45 degrees. Multiply by 2 minus F2. Now what is the value of F2y? F2y, as you can see here, F2y is F2 cos 30 degree, right? F2 cosine of 30 degrees multiplied by 4, it is equal to m. We have to find the value of m. Now what is the value of F1? It is 8.965. 8.965. So I will put the value of F1 here. This is cos 45 multiplied by 2. Now F2 is negative 7.32. Now this is negative and this is negative, so it is going to be positive. Okay, so let me use the calculator to find the value of this equation. So it is 8.965 multiplied by cos 45 degrees multiplied by 2 plus F2 is 7.32, right, multiplied by cos 30 degrees, cos 30 degrees multiplied by what? 4. Okay, I get the value 38.0356, which is approximately 38, right? It is equal, all of this is equal to 38, right? Now this is equals m. Now F1 is the force. F1 is in kilonewton, right? F1 is in kilonewton, because you see this is 10 kilonewton and we found the value of F1 and F2 but we put the value 10 kilonewton, so it is F1 is kilonewton. Now 2 is what? 2 was distance and the distance is meter, right? Kilonewton meter. So 38 kilonewton meter is a unit. It is equal to m. So what we find the value of m? M is 38 kilonewton meter. Now is it clockwise or anti-clockwise? Now since we get a positive value 38 kilonewton meter, it is a positive value. it means because we have assumed the clockwise moments are positive, so we got this moment which is clockwise, right? Because clockwise moments are positive. Now which option is correct? As you can see here, option B is correct. Okay, now if you have any doubts, you can comment, and I again suggest you to please watch the video lectures in sequence in the playlist, okay, because that way you will understand better. So if you have any doubts, please comment. And this is how we solve the problem on equivalent force systems. So see you on the next class. Thank you.